Hi guys, this is solving trig problems using the unit circle. So in the previous video, we saw the unit circle, we saw kind of how it was constructed, we saw, how to read the stuff around the unit circle, what these things are, what those means, what the degrees, what these radians are, what these xy coordinates actually mean. So we learned how to read it. In this video, we're going to be going through a couple example problems, and in fact, we can just see them here. So we're going to solve all these problems, and we're going to solve them all by using the unit circle. So in what quadrant is sine greater than 0 and cosine greater than 0? We're going to find the sine, cosine, tangent, the reference angle, and the quadrant for 300 degrees and 2 pi over 3. We're going to answer the question if sine of t equals 4/5 and it's in quadrant 1. What is cosine of t? So we're saying if t is in quadrant 1. What is then the cosine of t? And what is sine of pi over 4 times cosine of negative 5 pi over 6? And what is sine of negative 5 pi over 4 times cosine of 11 pi over 6? So if you want to pause the video now, try these out on your own, you can, but otherwise we're going to go through these now. Alright, so in what quadrant is sine greater than 0 and cosine greater than 0? So always remember, sine is y, cosine is x. So in what quadrant, oh sorry, that's less than 0. In what quadrant is our y values greater than 0, which means positive y's? So where do we have positive y's? Well, y's are height, so positive y's happened anywhere on the top of the unit circle. Cosine less than 0, so we want negative x. So where is x negative and y positive? Well, it's in this quadrant over here. It also tells us here cosine is negative and sine is positive. So in what quadrant? Quadrant 2. This whole quadrant right over here. That whole thing in that whole quadrant, all cosines are negative and all sines are positive. Alright, so that was number 1. Next, here's a long one. Find sine, cosine, tangent, reference angle, and quadrant for the following angles. So we'll do A, I'm going to erase it, and then we'll do B. So 300 degrees. What is the sine of 300 degrees? Well, first, let's find where this angle is on our unit circle. 300. 300 is here. So I'm going to circle everything that goes with the 300. Okay. So what is the sine of 300? So remember, sine is the y value. Cosine is the x value. Tangent is the slope, which is y over x. So we're going to use all this to solve the sine, cosine, and tangent. Okay, so sine of 300 equals the y value of this coordinate, so negative root 3 over 2. Cosine 300 equals the x coordinate of this value, so that's 1/2. Tangent is the y over x, or sine over cosine. So what is negative root 3 over 2 divided by 1/2? And dividing by a fraction, so let's do some quick algebra. Dividing by a fraction is the same thing as multiplying by its reciprocal. Those guys knock out negative root 3 over 1, which is better known as negative root 3. So there's the tangent of 300. Oh, I forgot to actually write 300. There it is. Tan of 300 is that. Okay, what is this reference angle thing? Well, the reference angle is, okay, suppose this, like, quarter slice of the unit circle, we can break these into, like, this guy is like the 30-degree angle. This guy here is like the 45-degree angle, and this guy here is like the 60-degree angle. So that's what the reference angle is. It's saying, okay, well, how far from, like, one of our coordinate axes is this particular angle we're looking for here? So, for instance, if we just did this, what is this angle? Well, this reference angle here would be 60-degree reference angle. Right? Basically what we're saying is this slice here is like a mirror image of this slice here. And notice that our sines and cosines are really similar except for the signs are different, like the positive negative signs, right? Sine of 300 is root 3 over 2. Sine of 60 is positive root 3 over 2. Cosine of 300 is 1/2. Cosine of 60 is also 1/2, right? Because in this particular area, cosine is positive for both of these slices. The tangent is negative square root of 3. The tangent here is positive square root of 3. So we use the reference angle of 60 to say, like, hey, this stuff and this information is kind of like that stuff and that information. Okay, that's why reference angles are so powerful. Okay, and what quadrant? Well, it's quadrant here, so it's also in quadrant 4. So quadrant is that reference angle. We would say a 60-degree reference angle. If you want to be really fancy, you could say negative 60 degrees, but I always keep my reference angles positive. Okay, let's now look at 2 pi over 3. So remember, sine is y, cosine is x, tangent is the slope, which is better known as y over x. All right, let's find 2 pi over 3 first. 2 pi over 3, 2 pi over 3, it's right here. Here's all the information that goes with 2 pi over 3. All right, sine of 2 pi over 3 is equal to, sine is the y, root 3 over 2. Cosine of 2 pi over 3 is equal to, cosine is the x-coordinate, negative 1/2. Tangent is equal to tangent of 2 pi over 3. I keep forgetting that for tangent for some reason. Is y over x, or sine over cosine. So what is root 3 over 2 divided by negative 1/2? Again, dividing by a fraction is multiplying by its reciprocal, so that's root 3 over 2 times negative 2 over 1. 2 is canceled. This will be negative root 3 again. Why is that also negative root 3? Because look, it's actually the same line as our 300, right? So the same line should have the same slope. So the tangent of that was negative root 3. So the tangent of this is also going to be negative root 3 because it's the same line, the tangent's the slope. All right, reference angle. So the reference angle. So here's our axes. So we're looking at this slice here. So our reference angle is going to be, hey, what's the angle here? So what is that angle? So our reference angle here, well, how do I get from 90 to 120? Well, our reference angle would be 30 degrees. And quadrant, what quadrant is this in? This is in quadrant 2. So there we go. All right, let's keep going. Let's see what other kind of questions we can answer. So that was a long one. If sine of t is 4 over 5, and in quadrant 1, what is cosine of t? So what I'm going to do is I'm just going to draw quadrant 1 here. Quadrant 1, right, is the upper right. So, and then we have some line here. This is t, so this is the angle t. Sine, and what I'm going to do is I'm going to draw a right triangle so we can use some right triangle trigonometry. Sine of t is equal to, sine of any angle is equal to the opposite side over the hypotenuse in a right triangle. So which means if sine of t is then equal to 4 over 5, that means the opposite side is equal to 4 and the hypotenuse side is equal to 5. So the opposite side is you shoot clear across. This is the opposite side. The hypotenuse is always the longest side, or side opposite of the right angle. Okay. And quadrant 1 is important because in quadrant 1, both x and y are positive. So we know all of these guys are positive. So that's going to be positive, that's going to be positive. That's why quadrant 1 is important here. So what is cosine of t? So cosine of t is equal to adjacent over hypotenuse. All right, we have the hypotenuse. So we know cosine t is going to be the adjacent side over 5. So here's the adjacent side, the side next to t. How do we figure out what a is equal to. What could we possibly use? Oh, what's the thing to solve sides of a right triangle? Oh yeah, Pythagorean theorem, the thing that everybody remembers, right? A squared plus b squared equals c squared. So a squared plus 4 squared equals 5 squared. So a squared plus 16 equals 25, minus 16 on both sides. A squared equals 9, which means a equals positive 3. We don't want the negative 3. So a is equal to positive 3. So this is equal to, not question mark anymore, that's equal to 3. So then cosine t then is equal to the adjacent side, which is 3, over the hypotenuse, which is 5. And done. So this hinges on knowing some right triangle trigonometry, like sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. If you need help on those, sine, the way that I remember it, so sine, cosine, tangent, I remember it as old hippies are high on acid, which is like the least PC way to remember this, but it's what I was taught in school. For some reason that was totally okay to teach when I went to school, but I still to this day, like when I say cosine, I'm like, oh, r high, so that's adjacent over hypotenuse. So if you like that, keep it. It's the one that I use. Alright, let's go to our next problem so we're not running out of time here. Alright, how do we solve these guys? Well, we need to figure out, okay, sine of pi over 4. What is sine of pi over 4? Let's go to pi over 4. Sine of pi over 4 is root 2 over 2, because sine is the y. So what is root 2 over 2 times cosine of negative 5 pi over 6? So if we're going negative, we're going this way. Okay, so this is pi over 6 then. This is negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. Negative 2 pi over 3, negative 3 pi over 4. This here is negative 5 pi over 6. So this is negative 5 pi over 6 here. I'm just counting backwards. We're taking the cosine. So negative root 3 over 2. Multiply these guys together. Root 2 times root 3. That'll be negative root 6. 2 times 2 is 4. Alright, what about sine of negative 5 pi over 4? Let's erase these marks that I have here. Sine of negative 5 pi over 4. So let's count backwards again. Negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2, negative 2 pi over 3, negative 3 pi over 4, negative 5 pi over 6, negative pi, negative 7 pi over 6, negative 5 pi over 4 would be here. Alright, we want the sine, so we're going to take the y value, root 2 over 2. Cosine of 11 pi over 6 is here. Cosine is the x value, times root 3 over 2. That'll be root 6 over 4. Done. Okay, let me erase. Alright, so we got through those in a good amount of time. If you guys have any questions, you know where to find me. I hope that video helped. If anything, just to show you kind of the myriad of problems that you can solve using the unit circle. My advice to you is print one of these things out for however long you're doing trigonometry. Have it at your fingertips. The best thing you could do is memorize the thing, but if you can't memorize it, have it as a quick reference guide. It can solve almost any trig problem that you need it to solve. If you guys have any future questions, please don't hesitate to ask.